Okay, it looks like it's time to start. So, hello everyone. My name is Grzegorz Piwowarek, and today I'd like to talk about something I've never spoken about in the past. So, microservices have been around for a long time, but I have not yet been through my microservice speech phase. So it's time to catch up with that. Um, I am an owner and independent consultant at a small boutique company. We do mostly workshops and consultancy. You can find some of my articles at forcomprehension.com. And since quite recently, I'm a fresh Warsaw Java user group leader. So a quick reminder, all the questions go to Slido, which will be addressed at the end of the presentation. So I've been working with microservices or with various attempts at microservices for somewhat close to 10 years. And I think I've been only in one project which was more or less successful implementation of that concept. But in other projects, some of them I worked on myself, some of those I consulted, some of those I just happened to work with people during workshops that experience certain issues. And the thing is that if you look at those, if you look at those issues closer, you'll see that there are some themes that keep repeating. So there are sometimes quite specific and unique issues, but there are quite a lot of those that keep repeat. So, and my point for today is to bring up 6 of those issues based on real stories and bring it to your attention and suggest potential improvements on how to move forward to not experience those issues if you happen to work with a microservice-based project in the future. So there are multitudes of talks about microservices. There are multiple books about microservices, but it all feels like we keep repeating the same story. So we end up with big unstructured project, which is a big pile of mud, and then we hope that suddenly, if we suddenly rewrite it to microservices, we'll get better. But quite often the problem is we don't end up with a better situation. We end up with something that's, well, it's better in some of the aspects, but in many others, overall, the experience is much worse. And in order to be successful with microservices, you need to adapt a different mindset of working with the whole idea. It's not enough to just slice your code base in random parts, put those together, and expect this will get better. Well, if it don't get better, just use a service mesh, right? At the end of the day, well, maybe this will help, but usually it doesn't. So, but before we go straight into microservices, let's recall that guy. That guy invented a null reference, and long time ago, and he called it his billion-dollar mistake, because apparently that's how world would look like if he hadn't invented that. So let me try to make a very bold statement about another billion-dollar mistake that was made in the recent couple of years. And that's microservices. But don't get me wrong, not the concept of microservices, but that micro in the name. So when I join projects and I see quite often a size obsession. So people start obsessing about the size of a microservice. So what actually is that micro part? How's microservice different than a service? How small is micro? So is it just a number of lines of code? So is 5,000 lines of code microservice already? And 10,000 lines of code is a macro service already? Not sure. Another metrics you could use is, well, for example, number of classes. Well, is 10 classes a microservice? Is 100 classes microservice? No one really can answer that. Maybe the size of a deployable matters. So maybe you measure the size of a microservice in megabytes. Some people do actually propose a metric that it's about the property of a microservice, that it can be rewritten in a certain amount of time, usually one or 2 weeks. But the problem is that this size is not really very much relevant at all. So we keep discussing what's the right size. We keep discussing what's the right number of microservices, the right number. So I've joined one project once, and they told me they had 60 microservices, and they were proud of that. Like, we have 60 microservices. Look, this like it denotes that it's a good architecture. And they added already that we are planning on adding 20 more. And yeah, okay, that could work in certain scenarios, but if at this point someone is suggesting that they already know that they are going to add 20 extra services, that sounds like potential sign of a cargo cult. Like, we are adding them because we are adding them, not because we really value what this gives us. And so my question goes, okay, so you have 60 services, but now you want to aim at 80. So remind me again, how many of you are in the team? 6. Okay, so there are 6 people working on 60 microservices, planning on adding 20 extras. I can think of some scenarios where this could work, and that would be a good choice. But in most cases, when there is a small number of people producing huge number of services, it might be a sign that something is not really going very well, and it's a sign of a cargo cult. What's more, then I'm asking, so actually, how many customers do you have? And they say 1. And I'm like, okay, 1 million, you mean 1,000, 1 million, what? I mean, like, no, 1. So all this obsession about the size and number of microservices ends up driving quite a lot of cargo cult and bad decisions. And teams that migrated into microservices, or even worse, started with microservices when they have not even yet experienced any pains of monolith, and it all goes to very bad. So let's recall quickly what's the main and the core idea of microservices. The idea of microservices is not just scalability, not dividing everything into small deployables because of something. But the main core idea of microservices is to enable scalability through independence achieved via modularity. But this is not mostly about scalability when it comes to how many transactions per second we can process, but it's more about organizational scalability. Because imagine that this is the map of your software. There are repositories, services, business logic, and it's all intertwined. The red dots designate one feature, yellow dot another feature. But for some reason, everything talks with everything. So features responsible for movie rentals, they, for some reason, access databases of warehouse management. And modules functionality responsible for account management, for some reason, needs to dig into some private utils of the warehouse, and so on. And it all contributes to the experience that we call big ball of mud. Because now, when there is some manager asking you to make a change in a software that's tightly coupled, they ask you to move that button 2 pixels right, and you say, oh, this could take anywhere between 2 hours to 2 months. Because of such tight coupling, making any changes is very, very hard. Because suddenly you need to make a very difficult surgery to change those dots, untie those dots, put those things around, and glue them together. But the whole point of modularity and microservice, I mean, one of the points, was to gain extra scalability by introducing modules. And we were very good at modularizing at very, very low level. Because what they teach us at university when it comes to encapsulation and abstraction is that we put fields private and getters public. And then someone ended up introducing modularity at very, very high level when being microservices. So suddenly now you can divide your whole system into independent pieces that communicate via well-defined public APIs, and this allows you to decrease coupling and increase cohesion. So if you put everything that's related close to each other into one service, and if you don't access implementation details of another service, so for example, their own database, you are technically free to do whatever you want inside that service. You want to throw away your framework, you can do that. You want to throw away your database and consume data from another service now, you can do that. You want to throw away everything and just keep everything in memory or just have hard-coded in your code. As long as you stick to the contract, that's fine. And that's a great property to have, because now, especially if you align your organization to that architecture. So the goal is you have a couple of teams, suddenly they are working on this big ball of mud, but you start experiencing friction. Suddenly, it's way harder to get pull requests merged on time. It's way harder to make changes because you feel like stepping on each other's toes. It's way harder to synchronize when it comes to the release time, and so on and so on. But if you introduce this structure, modular structure, where you have independence over what you are doing, suddenly it gets much easier, because now 60 people can work on the same code base that's been sliced into a few distinct services. And it's okay, because you paid extra cost for building infrastructure to make that possible. You replace your convenient JVM Java method dispatch, you replace it with network calls, well, which is way more fragile. But it's worth it, because suddenly your 60 people can work on 3 or whatever number of services without really hurting each other, because they are all working in their own section. But the good news is that some of those properties you can have without introducing microservices. So the base idea of modularity can be implemented in the middle level as well. So we don't need to modularize only at the very low level. At the high level, we can go somewhere in between and build a structured monolith where you can have separation between various functionality that's inside the service. It doesn't mean you need to immediately split it apart. You can have it all together in one until you start experiencing pain, until this is not enough. So probably when there's a team and there's idea, we are starting from microservices, especially for a system that doesn't exist yet, has no customers. That's probably a very sign that you will be cargo culting and doing some over-engineering. But if you really want to do some extra over-engineering at the very early stage of the project, it probably makes way more sense to start with a modular monolith first. Because that's not a lot of effort. It won't give you all the benefits of microservices, but it's cheap to implement. It's really cheap, and you don't really need to invest a lot of time and money into making this work. So when the time comes, when you really decide you need to split into microservices, you are ready to do that. But the thing is, so let's go back to the original question about the size of microservices. And the thing is, the smaller the size of a service, the more you maximize the benefits of microservices. Naturally, because the more modules you have, the more services you have, it's way easier to make changes in them and release them. So let's take it to the absurd level, and you have a service that's literally just one function. If you make a really tiny change in there, you're pretty much safe to deploy it, and you're quite likely to not break anything, because there's just a couple of lines of code. But the bigger it is, well, at the end of the day, you have a bit more worry when you make a change in there. However, the more services you have, you also increase the number of downsides of microservice architecture. And this is not linear. So the more services you have, the more you need to start worrying about things like, for example, distributed transactions. And suddenly, if your whole system is composed of very, very small microservices, this is quite likely to bring you more issues than value. But there are companies that make it work. So if you look at the graph of the whole architecture of Netflix from a couple of years ago, that's pretty much how it looks like. And they have thousands and thousands of services. But there's one very important context. They didn't start with that. They didn't start the whole company saying, okay, that's what we are building. That's something that they evolved over time, over a long period of time. And again, they need to make, at least before the layoffs, around 2,000 of engineers to work on the same system. So naturally, if there's a totally different challenge to make 60 people not kill themselves while working in the same system. But what if you have 2,000 people? Okay, that's definitely way more harder. So you will probably ask me, or probably you've already asked on Slido, so Grzegorz, tell me, what's the right size? So when do we split? So I think that there's no good answer to that, what's the right size, but I think I can answer a question about when to split. So when do we split? Remember the first rule of distributed systems. Really, don't do it if you don't really need to. So what worked for me and other teams in the past, that you start with a structured monolith or even with a monolith. And only when you start experiencing pains and pain becomes unbearable, that's when you split. But you don't split, you don't have one big monolith and then you don't suddenly split into 100 services. You start experiencing pain because there are too many people working. You can't agree on the release time. It's really hard to test, and so on. And it's very hard to get a PR merged because there are so many concurrent PRs at the same time, and it's really hard to move forward. So that's when you start experiencing problems and pains of that, that's when you split. But you don't split suddenly into 100, you split probably into 2 or 3 and so. And then you rinse and repeat. So if this is not enough, if you sliced your domain into 3, some modules, some services, and this is still painful, then you split. So you eventually end up with something that's a couple of services, but they minimize the number of downsides that you experience for microservice architecture, but you maximize the benefits. You have modularity, you have independence. So for example, instead of one big team, you form 3 teams working on 3 distinct subdomains of your system. And now they have independence to work on what they want. And you don't need to worry, for example, about approvals on a single monorepo from someone that you never really work with and someone that really doesn't know what you are doing in your part of the system. So what I really think, what should be a pragmatic default, and which most companies should be at, is something the DHH called majestic monolith, which is pretty much a fancy name for modular monolith. But the idea is that most companies probably should have one big monolith in the center with a couple of auxiliary outpost apps around it. And that's a sign of a healthy migration, that you've started with a real big ball of mud. And suddenly, when you've started experiencing pain points, you started addressing them. So you end up in the process of slicing the big monolith into small ones, but you live with the setup where there's probably one bigger one and a couple of smaller rounds around it. And those can be sliced because of various reasons. Because maybe this small piece of code needs to be really scalable with all the AWS auto-scaling magic and so on. Okay, that's a valid reason to slice it, so you take it out. But others might be sliced just because you want to enable organizational scalability. That's also fine. So to make it work, you also need to think about something else. It's not enough to slice your system into small pieces and suddenly benefit from that. You also need to adopt a new mindset. And this is very common. So we've sliced the whole service, the whole monolith into small pieces, but we still try to work with it just like we would work with a monolith. So what I've seen a couple of times is that the whole service is still versioned, the whole system is versioned like it's once. So we have 50 services, but we still generate the same version for all of them, and we deploy them all at once. Well, what teams told me, one team told me in the past is that they can. They can, of course, we can. We can ship those separately. We can deploy independently, but it's just safer not to. So they deploy everything. And that's really not how you gain organizational scalability if you have a couple of teams working on one microservice architecture, and then you need to force them to, agree on the time, reach consensus, when do we generate new version, and then when do we deploy. That's really where you, in such a setup, you will experience most of the pain points of microservices, but not much of the benefits. Another pattern that I've seen is that there is quite often old school dedicated DevOps bottleneck team somewhere along the way. So we've sliced my monolith into a couple of modules, and we've sliced the teams into a couple of teams. But for some reason, we don't give them independence. There is one team of infrastructure people that are asked to manage the deployments and releases. The problem with such setup is that quite often those people are not paid for fast delivery. They are quite often fast for ensuring safety when delivery. And what's the main enemy of safety? It's change. So quite often I saw this happening, that you end up with a big organizational friction. You end up in constant fights because people responsible for safety, they don't want to really help you in shipping fast, while your responsibility as a developer is to ship the product fast. So what I've seen working really well is that you kill that silo of a DevOps team, you spread those people around into particular teams working on their own services, and you give them independence. If you don't want to give admin access for the developers, at least have a dedicated person on the team who's tasked with making sure that delivery can happen smooth and often, instead of ensuring safety and sitting somewhere else in the organization. Because I've seen this totally cripple the whole process. Well, we've built 60 services, but well, we still need to wait for someone out there to sign everything off. And where's the value in that? I can't ship my change. I can't introduce value for the customer as soon as it's ready. I still need to wait for the big synchronization of a deployment. Another thing is end-to-end acceptance tests. At some point, when you slice your system into smaller pieces, you need to abandon the idea that you can test everything at once. Imagine and think about a crazy scale. Think about eBay, for example, or Amazon. Imagine making a full end-to-end test suite of the whole system they are building. And we are discussing thousands of services to be tested. Incredible, crazy amount of functionality. That can't be done. So at some point, you need to forget about the fact that you can test everything all at once and start thinking how we can make this delivery safe while testing pieces independently and testing contracts, for example, between them. Because essentially, if you slice your system into smaller pieces, you should work with them like you would work with independent systems. Like imagine you're integrating with if you are integrating with another service, think about it like you're integrating with a REST API of a third-party company that you don't have access to. Don't assume you know their internals. Don't assume you can test them together. It's some distant system that you are integrating with. So that's where, for example, contract tests will test you a lot. If you really want to test certain functionality, of course you can do that, but keep in mind that this is going way, way harder as the number of services and functionality grows. And at the end of the day, if you want to benefit from microservices, you need to make sure that you can deploy it by yourself and make changes by yourself. If you can do it by yourself without waiting for any external dependencies, then it's going to be hard to benefit from all those cool things that people mention in their talks and books. So what I noticed, another thing that happens quite often is that common monorepo versus repo per service philosophy. So you can make both work, definitely. You can make monorepos work, you can make the other one work. Monorepos are a bit more convenient, but there's one big problem with them. It makes it way easier to stick to old habits. So you've had one repo with a monolith. You were used to making big commit that touches onto multiple functionalities. You've sliced it into smaller pieces. Now it's monorepo. So if you have all those services in one monorepo, it's nothing really stopping you from making a commit to a couple different services at the same time. So the tooling makes it easy for you to work with the system just like it would just like with a monolith. And this is pretty tricky because that requires quite a lot of extra discipline and a lot of extra tooling. Because I assume you don't want to build all services at once, but only those that were changed, which gets pretty tricky. But if you dedicate extra time to having the repository per service, that's way harder, because suddenly, if you want to introduce backward compatible changes to multiple services, you are forced to make separate releases, separate pull requests. And you need to figure out a way how to make it in a backward compatible manner, instead of making a huge commit that touches 5 services, and then trying to synchronize the deployment. So, okay, I made this big commit, touches a few services, let's deploy them all at once and hope that they get up in the same time to not cause any issues. So that's a small thing, but personally I prefer solutions which don't leave you a lot of room for error. So instead of giving so much freedom to everyone and relying on discipline, I'd rather use a solution where it's really hard to make an error. And if you have a service per repository per service, it's a bit way harder to make those kind of mistakes you could make if you worked with a monorepo. Another thing that I have seen quite often is that, so you've evolved into microservices. So the team had 150 services already, but they all rely on synchronous communication, which means there are 150 services, but in order for the system to work, they actually all need to be up at the same time. So because of the fact that you need to make synchronous calls all around the place, the client initiates one request, but there is a myriad of requests, rippling for the whole architecture. And I can imagine this being the right choice, but in many cases, this will prevent you from benefiting from some of the cool things you could get from microservices. So generally, both are fine. And I noticed that you can both sync and async within one architecture. So for example, you would like to use sync communication when you want to be as consistent as possible, but async when the consistency is not so important. And I don't mean that you should abandon consistency, but instead rely on eventual consistency, which, by the way, is something you should probably start embracing in your microservice architecture, because guess what? You've split your system into a couple of services. So now you're prone to to fallacies of distributed computing and the problems that networking introduces. So if you really want to be fully independent, if you really want to benefit from this independence of your services, if you want to have your one functionality to be always available while the other is down, you need to forget about strict consistency and start embracing eventual consistency. So it's a very simple idea. So normally you would do HTTP GET and obtain data from another service. But in order to make this work, that service needs to be up and running. And the service can be overloaded, it can be down, something can be wrong. But in order to be independent from the other service, how do you rely on eventual consistency? So you introduce events. So service number 2, let's say it's responsible for user creation. Whenever a user is created, it would emit an event that you would listen to. But in your service 1, instead of calling the other service, you would build a local projection, a local read model of the data coming from the queue. And now, this data obviously is eventually consistent with what service 2 observed. But now, if the service 2 is down, you are still working fine. You are still providing functionality. So even if service 2 totally failed, your service 1 is truly independent. So if you can spot places in your system where you can actually relax consistency guarantees a bit, you could benefit from that a lot. But what I've seen so far is that most teams actually default to synchronous communication, and then suddenly it's problematic because one service in the even in edge case scenarios, one service is down and the whole system doesn't work, and that's not where you benefit most from microservices. So another thing, we're discussing about embracing eventual consistency, but there is one more thing we need to talk about. We need to distinguish between eventual consistency and accidental consistency, or permanent inconsistency guarantees, because this is very common. So we've decided to embrace asynchronous communication. So we no longer do HTTP calls, we rely on data coming from a queue. So here's a very sneaky problem in there. So that's our user service. You want to create a user, you send a post request to it. So it saves data in a database and then publishes an event. So now we have a problem, because what we have here essentially is a distributed transaction. Because what we care about, what we really want to, is that we want this to be saved both into RDB and to Kafka or any other message broker out there. But you want to save them atomically, both or nothing. And what's super common is that I always see there's some people trying to solve this with transactional. I don't think they are solving it actually consciously, putting the transactional here to solve this with transaction. It's more likely the transactional has been there, but suddenly now they are publishing an event, so it evolved a bit. And guess what? This will work most of the time, but when something gets wrong, so I can easily imagine a situation where you persist a user, you send a message over message queue, something gets wrong with the network, and you never receive the ACK. And if you don't receive an ACK, that means there's somewhere probably an exception there. An exception rolls back the operation that saved the database. So you ended up publishing an event, and you have nothing in the database. So all your read models that observed the ghost event now are broken. Good luck trying to undo that. So I've seen various attempts at solving this issue, and the most interesting one I found is that one team would inject a ping, RabbitMQ ping, right between the one and persist and send functions. Because the assumption was, if we persist a user and then ping RabbitMQ, and the RabbitMQ responds, it's quite likely if we try to send a message, it will go through. And it did work most of the time until some time where it didn't, and all our read models were corrupted. So what's the native way of solving that? There's a concept called change data capture, which means capture, well, as the name suggests, you try to capture changes happening in a database. Because the problem here is that you have two writes. You have a dual write, one to a database, one to a message queue. But you can't do this in transaction. But what you can do in transaction is a single write to a database. So instead of having those two writes, what you can do instead is you can have one single write to RDB, and then do that magical change data capture and notice that the change was made to RDB and then put it up and put it into a message broker. And there are a couple of ways you can implement that. So one of those, like the full-blown, is a transactional outbox pattern, which means you would create an extra table as an outbox, which would represent the messages that need to be pulled from a database and put in a message broker. And then you can use a tool like Debezium that pretends, for example, it's another DB, and it pulls the data immediately from the database and is able to relay then to Kafka, for example. This is, however, this requires quite a bit of work to make it happen. So the easiest way you can do this is if you accept a bit longer latency, you can even have a separate thread that polls the database, for example, every second, 5 seconds, 10 seconds, whatever makes sense for you. Obviously, this will be a bit worse. The latency will be much worse for the the difference between the database save and the message to appear in the broker. But hey, this still matches the definition of eventual consistency. You needed to be ready for that anyway. Of course, there will be a problem, because probably if you deploy this on a couple of instances, you are likely to have multiple messages being published at the same time. But you also need to be ready for that, because in the world of distributed systems, if you want to have guarantees that some message was delivered, you can't have at least once, you can't have exactly once, you need to be ready for at least once. So you need to think about how to handle repeated messages as well. Another thing that's quite common, it's the technology zoo. So one of the great benefits of microservices is that you can use multiple tech stacks together, and it should work just fine. So I think this is a bit overvalued, because, well, that's a great property to have. So suddenly, one day you're writing PHP, then next day you're writing Rust. Sounds great on paper. But the problem is that you lose. So the problem is that not really, I can't think of many problems where you would need such diverse set of technologies. So quite often when you see a diverse set of technologies in a microservice project, it's not because there was a real need to do that, but more because, well, we could do that, so we did that because that was fun, to try new things. And then you have a problem, because you have, let's say, 80 developers in your company. They all specialize in one technology, one tech stack, but you have 6 tech stacks. So in the past, when there was more or less one tech stack, if there was an accident and some people were gone from one team, someone else could take over. But now, if parts of your system are written in PHP, second part in Rust, first part in TypeScript, suddenly that's way more trickier. So my general suggestion would be, don't throw new tech unless there is a good reason for it. And don't get me wrong, the reason for it can be technical. So we can't do this in this technology, so we'll do this in another one. But there are other reasons why you could do this. So for example, we want to build competencies in a new technology. So we identify, let's say, a not very crucial part of the system, and we consciously let someone work, mix PHP and Rust if they really want to, because that's a learning experience. But consciously deciding to make a learning experience to upskill your team is different than just randomly throwing whatever you can. So what I've seen work the best is that actually have a standardized tech stack. You don't need to be very strict about it. But if you reach a conclusion that by default we do, let's say, Java and Spring Boot, you'll probably be way happier than letting every team start with a new framework on their own. And suddenly it's way easier, because when someone needs to jump over to another team, they can do that. Plus, it quite likely decreases the number of internal tooling that's happening. Because guess what? Quarkus, Spring Boot, Micronaut, they all, for example, do some things differently. Let's say distributed tracing. I mean, it's the same idea, the same. The headers are called the same, but still the way you do this is a bit different when it comes to the tooling. So it's quite likely to increase things that you don't care about, increase your reliability. So standardized tech stacks worked pretty fine. But of course, it doesn't mean you always stick to those things, but there is a room always for experiments. And the last thing I'd like to bring to your attention today is don't dry abuse and share libraries. So that's a very delicate topic, and dry is very contextual. Don't repeat yourself. And I think that being too strict about don't repeat yourself can lead to some disasters. So what I've seen a couple of times happening is that two things. So there, the monolith was sliced into microservices. There are suddenly 50 services, and someone notices that there is a repeating pattern. So we use Spring Boot everywhere. We use RabbitMQ everywhere. We use something else everywhere, and then another library in some services, and then something else. So usually someone with very noble gesture in mind emerges, and it's like, let's help our colleagues to not experiencing the pain of redeclaring same dependencies over and over again. So that's when a common lib is born. So you end up with a common lib, which probably has multiple versions of Spring Boot with all possible modules that you can find out there. But with time, it starts growing. People start throwing in all the possible tech in there. And someone notices, hey, there's this service that serves a couple of other services. And we have in those other services DTOs, Java classes that look more or less the same. OK, so don't repeat yourself. Let's put those in a shared library and just reuse. OK, someone figures out, OK, I really don't like how AWS Secrets Manager works because it throws exceptions, and I would rather it return an optional instead. So someone writes a wrapper on top of AWS Secret Manager and puts it in there. And then someone figures out, hey, when we do this particular functionality, we do really repeat that process a lot. Where do we put that? Well, don't repeat yourself. Let's put that in a shared lib. And that's how this monstrosity emerges, which usually has way too many dependencies on class path. It has shared DTOs and, worst case scenario, some shared business logic in there. And suddenly it becomes really difficult because it contributes to dependency hell, especially if you're working with Spring Boot applications. You don't want to have every possible dependency in your class path because Spring can make a decision based and some magic based on the fact what it can find on class path. It's OK when it's stable, but imagine you make a small to very small library somewhere in the common lib, which causes transient dependencies to update, and suddenly your auto-configuration breaks. Usually it's not the Spring auto-configuration, but probably you've built one yourself and put in that lib that was supposed to make your life easier. So if you do and then if you make smaller changes to those shared libraries, now you have two options. You can either bump the version up in all the services that rely on it, which mostly is almost everything, but then you would need to deploy pretty much everything at the same time to make sure it's running on the newest version of code. So most teams will probably do it at the beginning and then give up. So we're like, OK, we just changed this small DTO, we just bumped this dependency, so let's not deploy everything let's not bump this version into all services, but only those that seem relevant. And that's how you end up accumulating more and more changes. So this change that was really small and tiny, seemingly, is safe to deploy. And even if something goes wrong, well, you roll back, you know what to roll back. But let's say you've skipped 10 or 20 versions of your shared lib on one service. And then when you really need to make a change to the service, it turns out, oh, you actually need to update. You update, and everything breaks. Too bad. I mean, if it breaks at compile time or in test, that's great. But too bad if it breaks on runtime. So I'm not saying don't do shared libraries, but when you do them, treat them like libraries and not bags with code. So if you really notice that there is some concern that needs to be shared, captured and saved in the library, make sure this is small, make sure it's independently versioned, and avoid any excessive dependencies that are in there. If you think about DTOs and stuff like this, just don't do that. You want to have coupling at the level of contract and not Java classes. Because again, it's problematic to manage Java classes that you use for serialization, especially if you include some annotations in there. because suddenly those annotations that are in there, they can be interpreted in different ways by various services that have different sets of dependencies on their class path. So that's not fun. And what's more, be really careful about business logic. And if you ask me, don't do that at all. So if there is some concern that there is a repeating business logic in different parts of the system, you probably would be looking at the scenario of potentially merging some services because of some premature split, instead of encapsulating that repeating logic and putting it in a shared lib. So usually people are asking, so now I need to consume REST APIs of another services. Do I create my own DTOs? Yes, you do. That's a bit of extra work. Yes, it is, but it gives you safety and independence. Suddenly you own your own infrastructure that you need to consume another service. And that works much better than having one big bag of DTOs that you move around. So we are pretty much reaching the end of the presentation. Let me quickly recall what we've spoken today about. So my main point was, never ever start with microservices when you are starting out from scratch. Start with a monolith. You will be happy. It requires way less work. If you want to do a bit of extra, if you want to pay attention to the structure of a service and modules, introduce modularity in there, but delay the split until you experience actual pain. So now, congrats, you split your system into two. Now it's no longer, now it's a distributed system. So stop acting like this is just a one system. It's not. If you want to benefit, if you want to squeeze most value of your microservices system, those are two services, stop releasing them, stop versioning them, stop treating them like they are just a single one. So congrats, you are now, fallacies of distributed computing are your problem. So stop trying to rely on all the services, all the functionality being up all the time, and don't try to make everything consistent, because it will make things much worse. Try to identify spots in the system where you can actually embrace eventual consistency instead of fighting it. And lastly, pay attention to guarantees of your system. You might be thinking that you are sending an event atomically after some operation is happening, but quite often, if you inspect, it might not be the case, because your eventual consistency might not be even eventual, might be accidental. The same when it comes to consumption of events. Be ready that sometimes you are getting repeated events. So don't be surprised if you get multiple events with created user with the same user ID. And at the very end, avoid technology zoo. It's fun for you as a developer probably, but for the whole system, not so much. So thank you very much. I hope you benefited at least from one of those points I brought to you today. And let's have a look at some questions. So if it's only the pain because of team size, you can have modules in the repos, but build one monolith. Yeah, that's doable. That's a fair point. What complexity of a microservice is too much for some number of developers so that you have to split it? As I understand this question, it's more about, not about a microservice, but in service in general. So, well, the question disappeared, but let me answer it anyway. So the thing is, what kind of problems can you experiencing? So this can be technical driven. So for example, you identified there's one part of the system that really would benefit from horizontal scalability, but for example, you can't scale the whole service because, for example, well, you have some in-memory caching in different parts of it. So that's, for example, a technical driver that can make you split the service into another one, and then you have this outpost that scales horizontally while the rest of the monolith stays. But I would say that most of the pain points you are quite likely to experience, those are pain points of working with other people. So as your service grows, you will have more people working on that. You will have more pull requests. You will have more trouble merging your stuff because of the conflicts, because of constant changes, and all those people working on everything. So when you introduce this form of locality, there's no longer a problem because suddenly those are not 60 people working on one thing, but 2 times 30 working on their own things, which gives you some form of locality, just like you would do with thread local buffers in JVM, because it's way easier when you have your own smaller piece that you work on. Another thing is when you feel like you can't grasp the whole system. So at some point there is enough functionality, there's not enough of your brain space to understand what's happening in the whole service. That's another sign that you might want to split into smaller ones. Or perhaps it's just literally just too many people trying to work on the small things, producing functionality and trying to reach agreement when to release those things. Because maybe you have 2 functionality in your system. One changes very often, second not so often, and suddenly you have disagreements and problems. So when do we release? How often do we release? If the change is small, that's usually not a big deal because, well, you can probably release as soon as possible. But as the stuff grows, it becomes harder and harder. When some of the microservices are down, do you prefer to fall back to null response when synchronous response is needed or throw exception? That's a very implementation detail-like. So there are definitely cases when. So imagine if you are, for example, you have separate service that provides is a recommendation engine essentially and provides list of recommendations for you. So if you make a call in there, usually you get very detailed, very fine-tuned list of recommendations for some user. But let's say this service is down. So I can still probably do and provide some list of recommendations that's as a form of a fallback, which won't be as accurate as what the engine would produce, but I can still have my system running. But there are obviously situations where the service is down, there's nothing I can do, and then null response and exception is essentially the same thing. It just depends on how you handle it locally, but it's an information that something went wrong. Do you have an opinion on the new Spring monolith? So it looks interesting, but I've never worked with it on a real-life project. What's the strategy to merge? There's not time, so let me go to the more important question. What's the strategy to merge microservices to monolith? Okay, so that's a really good question. So when you've split microservices to monolith, generally I wouldn't probably put it back unless, again, there is very good reason to do so. So one of the main reasons to do so is that you've sliced them wrongly. So you feel that like they are both serving same functionality, they are tightly coupled, there's a lot of communication, then you put them together. So you essentially need to undo what you've done, and this gives you an opportunity to create a modular monolith, a small modular monolith. So essentially what you need to do is to identify the public-facing API for every module, probably create a single class that represents the whole public API, and this will be your single public entry point to the module. You put those in separate packages and slowly rewrite your HTTP calls into standard JVM method dispatch, and that's pretty much all. So the point is that when you merge them together, you probably, if there is functionality intertwined, you put them together. And I think there's nothing fancy about merging those. But if those are like separate functionality that you want to put into a single one, then you recreate modular monolith. Instead of creating DTO on service and service client side, we use a DTO contract jar dependency. Is it worse than duplicating DTOs into places? It's not necessarily worse, but it can get problematic. So this will work more or less fine if you have stable API. If your API is changing, you are likely to change this jar dependency a lot. And if you change this jar dependency a lot, it means that all your customers will need to keep updating as soon as possible, which makes it a bit harder, because when you make a change to an API, suddenly all those services should update as soon as possible, which means those should pretty much immediately get deployed. If you don't do that, you accumulate potential problems that will probably blow up when you are forced to upgrade and then go to production. I would personally avoid that because it gives you a bit more freedom. And usually it's not that hard to have your own Java classes. It's not that big of an effort. There's some duplication, but I can't really, if you are working in separate teams, you don't really feel the duplication, because if another team is consuming the API of another service, it's not really a problem. You don't really see those classes. There's another team building their own infrastructure for their own needs, which is probably configured slightly differently. So probably that contract jar dependency is probably not just simple classes, but some Jackson annotations and so on. And this can get tricky at times. My preference would be to not do that, instead of rely on open API specification if you want to share contract. OK, I guess that's all. Thank you.